Hello friends, how are you? In this video lecture of chemical kinetics, today we will see what is first order reaction, examples of first order reaction, integrated rate law in first order reaction, unit of rate constant in first order reaction, half-life period in first order reaction and a graphical representation in first order reaction. So to understand this, watch this video till the end. अगर आपको पसंद आता है तो like it, comment it, share it and subscribe it. In previous lecture, we have seen what is zero order reaction, integrated rate law in zero order reaction, unit of rate constant in zero order reaction, half-life period and graphical representation. आज के लेक्चर में हम देखेंगे what is the first order reaction. What are examples of first order reaction? Decomposition of hydrogen peroxide. When hydrogen peroxide exposed to light, it gives water and oxygen gas is released. So what is that reaction? Hydrogen peroxide, when exposed to light, it gives water and oxygen gas is released. So here rate of reaction is directly proportional to concentration of hydrogen peroxide. This is rate law in case of what? Decomposition of hydrogen peroxide. Second example, decomposition of nitrogen pentoxide. It gives nitrogen dioxide and oxygen. So again, this is an example of first order kinetics, and here rate of reaction R is equal to K into concentration of what? Nitrogen pentoxide. First order kinetics. Conversion of cyclopropane into cyclopropene. Again, this is an example of first order kinetics. Decomposition of cyclopropane into propene. Here hydrogen gas is released. First order kinetics. So these are the few examples of first order reaction. Now integrated rate law in first order kinetics, first order reaction. Consider A to B. यहाँ पर A reactant है और B product है. So what is the rate of reaction? Rate of reaction R is equal to, we have seen, हमने देखा है what is rate of reaction, decrease in concentration of reacting molecule per unit time. And a reactant का concentration decrease होता है, simultaneously increase in concentration of product per unit time. So here, in terms of reacting molecule, minus d by dt of A. This is the rate of reaction. A equation number 1. Negative sign indicate क्या करता है? Decrease in concentration. dA, change in concentration, final minus initial. What is the dt? A time interval. Rate of reaction is also known as the velocity of reaction. Yeah, change in concentration per unit time, decrease in concentration of reactant per unit time. So this is what? Rate of reaction. Now for the same equation we can write rate law. R is equal to, what is rate law? A rate law क्या होता है? It is simple equation in which rate of reaction is expressed in terms of what? Concentration of reacting molecule. So here R is equal to K. A rate constant होता है, concentration of reacting molecule A. Equation number 2. Now compare these two equations. इन दोनों को कंपेयर करना है. लेफ्ट हैंड साइड सेम है, सो वी कैन राइट माइनस डी ए बाय डी टी इज इक्वल टू के इंटू कॉन्सेंट्रेशन ऑफ ए. I will take concentration terms to one side. ये डी ए कॉन्सेंट्रेशन, चेंज इन कॉन्सेंट्रेशन है, यहाँ पर ये concentration of reacting molecule. So I will take concentration terms to one side. In the same equation we can write dA upon A is equal to, now K into dt. Now shift this negative sign to this side. Equation will be dA upon A is equal to minus K into dt. Equation 3. Now after integration of equation 3, इसको integrate करना है. You know what is integration? A mathematical concept है. We know that integration of dx we have seen in last lecture. Integration of dx. We know that integration and derivative, these two are exactly opposite processes. So integration derivative it will be cancelled. So x plus c. इसी क्या होता है? इंटीग्रेशन कांस्टेंट होता है. सिमिलरली dx अपॉन x, इंटीग्रेशन ऑफ dx अपॉन x, इसका इंटीग्रेशन होता है log of x plus c. अगेन c क्या है? इंटीग्रेशन कांस्टेंट. ये log of x ln x ये नेचुरल लॉगरिथम होता है, यानी फॉर दिस वी कैन राइट log of x to the base e. अगर इसको जनरल लॉगरिथम में कन्वर्जन करना है, सो आई वांट टू कन्वर्ट दिस नेचुरल लॉगरिथम इनटू जनरल लॉगरिथम, सो वी हैव टू मल्टीप्लाई इट बाय 2.303 log of x to the base 10. तो यहां पर dA अपॉन a, इसका इंटीग्रेशन लेना है. सो इंटीग्रेशन ऑफ dA अपॉन a इज इक्वल टू, ये रेट कांस्टेंट है, we can take it outside of the integration, that is minus k into integration of dt. So इसका इंटीग्रेशन क्या होगा? इंटीग्रेशन ऑफ dA अपॉन a, it will be what? log of a plus c. लेकिन इसके लिमिट्स क्या है? व्हाट आर द लिमिट्स ऑफ इंटीग्रेशन? इनिशियल कॉन्सेंट्रेशन when t is equal to 0, when time is equal to 0, इसका कॉन्सेंट्रेशन होगा A0, रिएक्टिंग मॉलिक्यूल का कॉन्सेंट्रेशन A0. आफ्टर सर्टन टाइम t, जब टाइम t होगा तो रिएक्टिंग कॉन्सेंट्रेशन, रिएक्टिंग मॉलिक्यूल का कॉन्सेंट्रेशन होगा AT. ये लोअर लिमिट है, ये अपर लिमिट है. इन केस ऑफ कॉन्सेंट्रेशन, इन केस ऑफ टाइम ये लोअर लिमिट है और ये अपर लिमिट है. सो बाय पुटिंग लिमिट्स हियर इट इज A0. Your final concentration after time it is AT. Exactly in case of dt, here it is 0 and t. So what is integration of dA upon a? It is log of a. So we can write log of a. Now limits, lower limit of this A0. What is upper limit? It is AT. Is equal to, now minus k. Now what is integration of dt? It is like a dx. So integration of dx is equal to x plus c. यहाँ पर integration of dt it will be what? t. What are limit? 0 to t. Now put upper limit and lower limit. So here upper limit at, यानी same equation we can write log of at minus log of a0 is equal to minus k. यहाँ पर अपर लिमिट है t, लोअर लिमिट 0, यानी t minus 0, it is t only. Here it is t. In mathematics we know that log of at minus log of a0. We can write here log of m minus log of n is equal to log of m upon n. ये मैथमेटिक्स में रूल है. So same equation we can write log of at upon log of a0 is equal to minus kt. मुझे नेगेटिव साइन हटाना है, so I can write here reverse of this log of a0 upon log of upon at is equal to kt. Now same equation in terms of k, rate constant k is equal to, now shift this time to this side, and 1 upon time, 1 upon t into log of a0 upon at. ये नेचुरल लॉगरिथम है. अगर नेचुरल लॉगरिथम को जनरल लॉगरिथम में कन्वर्ट करना है तो उसे 2.303 से मल्टीप्लाई करना पड़ेगा. एंड सेम इक्वेशन वी कैन राइट k इज इक्वल टू 2.303 upon t log of a0 upon at. So this equation is said to be integrated rate law in first order kinetics. K is equal to 2.303 upon t log of a0 upon at. A0 initial concentration of reacting molecule. What is AT? This is the final concentration of reacting molecule. Unit of rate constant in first order kinetics. K is equal to, we know that 2.303 upon T log of A0 upon AT. Now इसका यूनिट निकालना है. So here unit of K, ये 1 upon time है into A0 a concentration of initial concentration of reacting molecule, a concentration है. डिनोमिनेटर में भी concentration of reacting molecule after time t, यानी यहां पर भी concentration है. ये concentration कैंसिल होगा. यानी व्हाट इज यूनिट ऑफ रेट कांस्टेंट इन फर्स्ट ऑर्डर काइनेटिक्स? 1 अपॉन टाइम, यानी टाइम इनवर्स. अगर टाइम सेकंड्स में तो यूनिट क्या होगा? सेकंड इनवर्स. अगर टाइम मिनट्स में सो यूनिट विल बी मिनट इनवर्स. अगर आवर्स में सो इट विल बी आवर्स इनवर्स एक्सेट्रा. यानी टाइम इनवर्स, दिस इज द यूनिट ऑफ रेट कांस्टेंट इन फर्स्ट ऑर्डर काइनेटिक्स. Now different forms of rate equations in first order kinetics. Already we know that K is equal to 2.303 upon T log of A0 upon AT. Suppose A0 is equal to A and a small a initial concentration of reacting molecule. Suppose X amount of reactant got reacted after time t. So what is AT? What is the concentration of AT? It will be A minus X. And the same equation we can write here, K is equal to 2.303 upon T log of A upon A minus X. Now what is exponential form of this first order kinetics? Exponential equation. Exponential form of rate law. We know that AT log of AT upon A0, we have seen, equal to minus KT. Equation है. By taking antilog of both sides, antilog of AT upon A0 equal to antilog of minus KT. We know that antilog and log opposite है, ये कैंसिल होगा. यानी AT upon A0 is equal to, अभी इसका एंटीलॉग है, एंटीलॉग ऑफ माइनस KT, it will be e to the power minus KT. So same equation we can write here, AT is equal to, I will shift A0 to this side and it is A0 e to the power minus KT. So this equation is said to be exponential rate law in first order kinetics. Now what is the half-life period in first order kinetics? Half-life period. Here initial concentration of reacting molecule is A0. जब टाइम 0 है, when t is equal to 0, what is initial concentration? It is A0. अभी हाफ लाइफ टाइम क्या होगा? t is equal to t half. तो यहां पर AT की वैल्यू क्या होगी? यानी आफ्टर t half, what will be the concentration of reacting molecule? Exactly half of this, यानी it will be A0 upon 2. Now put these values in equation number. Suppose this is 1. So K is equal to 2.303. अभी यहां पर T क्या होगा? T half log of initial concentration A0, लेकिन after half life AT का concentration यानी concentration of reacting molecule क्या होगा? A0 by 2. I will take T half to this side, is equal to 2.303 upon K to this side now. लॉग ऑफ, अभी a0 कैंसिल होगा, ये 2 ऊपर जाएगा यानी लॉग ऑफ 2, ये बेस 10 है यहाँ पर, बिकॉज ऑलरेडी वी मल्टीप्लाइड दिस बाय 2.303, so k t half is equal to 2.303 upon k. Now what is the log of 2? It is 0.3010, यानी t half is equal to 0.693 divided by k. This is the half-life period in case of what? First order kinetics. In a zero order reaction, we know that in case of zero order reaction, we have seen t half is directly proportional to concentration of reacting molecule. Initial concentration of reacting molecule, isn't it? So t half is directly proportional to initial concentration of reacting molecule. In case of first order kinetics, here t half any half-life period is independent on concentration of what? Reacting molecule. यहाँ पर t half is directly proportional to concentration of a to the power 0, and we know that a to the power 0 and anything to the power 0 and it is 1, and it is independent on concentration of reacting molecule. Now graphical representation in first order reaction. Graph number 1, concentration of AT and concentration of reacting molecule after certain time t versus time. We know that exponential form of rate law in case of first order kinetics. What is that equation? AT is equal to A0 into e to the power minus KT. इसका मतलब क्या होता है? डिक्रीज इन कॉन्सेंट्रेशन ऑफ रिएक्टिंग मॉलिक्यूल एक्सपोनेंशियली with time. So what is nature of graph? X-axis I will take time, and यहाँ पर concentration of reacting molecule. Exponentially decrease in concentration of reacting molecule with time, and a graphical representation will be like this. And as the time increases, concentration of reacting molecule decreases exponentially. A graph number 1 है. Now graph number 2, this is the first graph. Graph number 2, we know that k is equal to 2.303 upon t log of a0 upon at. For this we can write log of a0 upon AT is equal to, I will shift this total term to this side and a k into t upon 2.303. ठीक है, अभी ये log of a0 upon at, so we can write log of a0 minus log of at is equal to k upon 2.303 into t. Now I will rearrange this equation. Log of AT is equal to, so I will shift this KT upon 2.303 to this side, and it will be minus k upon 2.303 into t plus log of A0. Now you can compare this equation with y is equal to mx plus c, straight line equation. यहाँ पर m क्या है? स्लोप है, and what is the value of m? m is equal to minus k upon 2.303. Second graph, so log of AT versus what? Time. And on x-axis again I will take time, and on y-axis log of AT. यहाँ पर स्लोप नेगेटिव है, स्लोप इज नेगेटिव. दिस इज स्ट्रेट लाइन इक्वेशन. y is equal to mx plus c, and a graphical representation will be like this. a स्लोप होगा, यहाँ पर स्लोप m is equal to minus k upon what? 2.303. Third graph, I will plot third graph, log of A0 upon AT versus time. Again, take the same equation, K is equal to 2.303 upon T, log of A0 upon AT. So I will keep this term to this one side, that is a log of A0 upon AT is equal to K into T upon 2.303. Again, you can compare this equation with straight line equation. Y is equal to mx plus c. यहाँ पर c इंटरसेप्ट 0 है, यहाँ पर स्लोप m इज इक्वल टू k अपॉन 2.303, यहाँ पर स्लोप पॉजिटिव है. सो व्हाट इज द ग्राफिकल रिप्रेजेंटेशन? यहाँ पर c 0 है, अगेन ऑन x एक्सिस टाइम एंड ऑन y एक्सिस log of A0 upon AT. Intercept C is 0, slope is positive, and a graphical representation, straight line passing through origin. So here it is, m is equal to k upon 2.303. So this is about graphical representation in first order kinetics. Examples of first order kinetics: decomposition of hydrogen peroxide, decomposition of nitrogen pentoxide, decomposition of cyclopropane. Integrated rate law. What is unit of rate constant in first order kinetics? It is a time inverse. अगर टाइम सेकंड्स में तो सेकंड इनवर्स, अगर टाइम मिनट्स में तो इट विल बी मिनट इनवर्स, अगर टाइम डे में तो इट विल बी डे इनवर्स. हाफ लाइफ पीरियड इन फर्स्ट ऑर्डर kinetics. T half is equal to what? 0.693 upon K. And in case of first order kinetics, half life period is independent on concentration of reacting molecule. And finally, graphical representation in case of first order kinetics. If any doubt, you can put your doubt in comment box. Definitely, I will get back to you. Thank you.